Hey there, welcome back. It's been quite a few days that I have made a video. Due to personal reasons, I couldn't post a video for quite a long time. So now I'm back. So as far as I remember, the last video that we made was, how to, professionally deploy a production level Next.js application into our AWS cloud. Okay. So I walked you through the high level architecture and infrastructure diagram and how this could be done. I think I gave you enough theoretical details to get started with. Now I just wanted to, continue from there and accomplish each module at a time and then see that in action. So for that, as I already mentioned, we are going to take the reference example as resume builder and parser. Okay, so this is the repo that we will take this as a reference. So first, just go ahead and clone this repo. So I'm just going to show you that. Okay, so let me, here I have in here already the cloned part. Okay, so let me just have this. Yeah, basically let me, yep. Yeah, so this is the repo. So I just cloned this and I have it locally in my system. So just, git clone and then use this URL so that this repo also sits in your local machine. Once you have that, I would highly recommend, to just go ahead and remove the git file in the repo so that this will be a non-git repo and you can just get started to create a new git repo and then push to other remote repository that we are going to do it, not right away, but eventually I'll push it to other repository. Okay, so and also here, I think this is the architecture diagram that we have been through and how to create the VPC network, that module, application load modules and other things required for us to deploy on AWS cloud. Okay, so I just don't want to talk much. I just wanted to get started. So first thing, so since we are in the root location of our application code, so let's create here the separate directory for infrastructure. Okay, this is mkdir. I think I misspelled this. Okay, so here I've just created in here the infra directory so that we can separate all our infrastructure related code into this section. Okay, so since for any module or to, I mean, I'm talking about Terraform module, there are three core important files if we want something to call it as a module. So that is main.tf, then output.tf and variables.tf. So you'll understand the importance of these three files, to together call it as a module. I mean, to give you at a high level view, variable.tf is nothing but the input variables that we can configure for this modules. It can be the name of our application, the port number, or the default region, or whatever required for particular service that we are using. Then output is nothing but, let's say, like, we are expecting some IP address or a public URL of our instances. Once we create that, and we are going to use that to, navigate through our application. So that we are going, those kind of things we are going to define in output.tf. And main.tf, the main code sits there of creating particular resources in our cloud and all stuff. Okay, so quickly I'm just going to create in here the three files, the main.tf. Okay, and I'm just going to create in here this output.tf and then the variable.tf. Okay, I just misspelled this, so I'm just going to rename this to tf. Okay, so now we have this three files in our main infrastructure file. Okay, so quickly let me define the variables that are needed for our module. Fine. The first variable that is needed for us is the region that we wanted to deploy our infrastructure in. So I'm going to give in here this AWS region value. So by default, we will try to stick to this US East region. Okay, and then the project ID, so nothing but the name of our project. So this one I just wanted to give in here the name as like something like resume builder application. Okay, and finally the environment that we wanted to create the infrastructure for. So by default for now I'm just giving the value as a prod environment. We can change this to whatever staging environments, dev environments, whatever is convenient for us. Okay, so these are the variables for now, and as we need it we'll come back to this file and then add this environment variables or whatever other variables. Okay, so switching to the main file. So here we are going to add the provider. So the main provider for us, it's going to be the AWS cloud provider. That is where we'll be deploying our infrastructure. So I'm just going to define here the core block here, nothing but the Terraform, and wrapping the provider inside the required providers. So this is going to be, so basically we can just refer the documentation here. So if you wanted to refer to the provider, so this is where we can just refer to the adding a particular provider. So again I'll just take whatever I have in this official registry documentation, so I can just mention the same. So this is the provider and the version that we'll be using, and then so the region. So here we can configure the specific details for this provider. So in this case the region, so since we have variable block defined, so now we can just refer to this AWS region which we just defined in this variable.tf. Okay, so that is the thing. And then the locals variable, I'm just going to define the target port of our application, which is the 3000 in our case, because this is the next JS application where we are mainly having the application on 3000 port. Okay, so here let me just define in here this target port as the variable. So I'm just giving in here the value as 3000. Okay, so this is like simple and rough configuration for the variable and then main.tf. Okay, now let's focus on step by step module wise. So first thing I wanted to focus on this network module. Okay, so basically so it's a best way if you want to isolate the snippets or Terraform configuration code via module, so that those will be like reusable for other people as well. Ideally these are separated as a modules and hosted in remote git providers or whatever, and then used across projects, so that redundancy of the same code writing again and again is avoided. Okay, so for that here I'm just going to create in here the new folder called modules. Okay, and in that I'm just going to define the module for each category that we are going to have a Terraform scripts. So first is the network module. So if, as I already mentioned, if you want something to be called as a module, we should have this 3 files. So quickly I'm just going to create in here this main.tf, the output.tf, and variable.tf. Okay, so here, and finally this output.tf. Okay, so it's very important if you first try to define the what is the input variables that we are expecting for particular module, and what is the output we are expecting from this module to give us and utilize for us in other modules and all. So if we have those values clear in our mind, so it will be better to get started with. So for this networking module, so first since I already walked you through, what is it going to be the so here you already saw basically the network module. So ideally we would need the CIDR block values, and also subnet for private and public, and also the availability zones, where we wanted to have this hosted, so that values basically we can take that as an input. At the same time the environment that we are targeting to, and the ID, again this is going to be something like the name of our application. Okay, so let me quickly define so that you'll get a better understanding. So I'm just defining this variable name as subnet public CIDR block. So we can define whatever the name is meaningful for us. I'm just naming this as subnet public CIDR block. Okay, so the default values that I'm going to assign in here is this IP addresses. So basically 10.0.1.0 24. Basically we are fixing this 24 bits, and this 8 bits we have, so basically these many number of IP addresses can be allocated or used by us. So nothing but 0 to 255, so nothing but 256 IP addresses can be allocated for us in each availability zones or whatever. Okay, okay, and here again I'm just fixing this as the 2, and same like the above. Okay, and we'll have to specify the type of this. Okay, so here this is going to be nothing but the list of a string, so this is just one variable. Okay, same way we are going to define for the private subnet. Okay, so I'm just going to define in here the CIDR block. Okay, and here as well, let's me just give the default value for this 10.0.11.024. okay, so same way I'm just going to fix one more number 12, and have this thing. Okay, and again this type is going to be same as the above, the list of string. Okay, so these are the two variables related to CIDR. Okay, and now this is related to availability zones. Okay, so by default I'm just going to again this is going to be list of strings. So default we are going to have our infrastructure hosted in two availability zones. Okay, so I'm just default assigning the US East 1A region and 1B zone. Okay, so not a region, and here this is going to be, yep, and here I'm just going to mention here this type, which is going to be type of string. Okay, and the project ID, so I'm just going to give here specifically this is just the web application. So basically we'll have APIs, application backend, applications deployed and all. So to be better clear of what this application is, we can just name whatever we want. So for now I'm just assigning the default value as a web app. Okay, and type I'm just assigning this as a string. Okay, and then finally the environment variable. Okay, so this one I will just assign for now it as a dev. Okay, and this type it's going to be string. So these are the variables that are needed for our network module. For now these are the thing that I think we required. So if we need additional variables we will come back and add in here. Okay, so okay, I did a mistake in here. So this has to be part of this variable.tf, not output.tf. Okay, fine. So that is the variable. So now coming down to the main.tf, the core snippets or the resources that we are supposed to create goes in here. So let me just define firstly the locals variable so that we can use across resources in this file. Now first is this Nat Gateway. So basically we are going to create this Nat Gateway. I can create this based on particular condition. Basically how many Nat Gateway I want, I'm going to determine dynamically based upon the subnet private CIDR block variable that we have defined. So basically if it is greater than 2, so for now, since we have two values, we are going to go with just one NAT gateway. Okay, if it is above 2, the number of the CIDR block that we defined, we are going to create that many. If not, just one NAT gateway. Okay, so if you want to accomplish with certain conditions and the creation of these resources, this is how we are going to do it. Okay, so I'm just going to name this as NAT gateway count. Okay, so here let me, so to get the length of that, I'm just going to refer to this private CIDR block variable. So if this is greater than 2, then I'm just going to create this many of this NAT gateway. So nothing with this variable dot subnet private CIDR block. Okay, if not, okay, so I'm just going to create one. So simple if else condition. Okay, so if this becomes true, so this value will be assigned. If not, 1 will be assigned. So better if we as we go on writing the Terraform configuration scripts, it's better if we comment and add a brief description what it does, so that for our future self or to other people it will be very helpful for them to refer and understand what this piece of line exactly does. Okay, so I highly recommend to follow this in your day-to-day activities, so that it will be helpful for yourself. Okay, for your future self itself. Okay, so I'm just going to give in your brief description. So I can say this is like, mainly like something used to determine how many NAT gateways, something like this network interface or this route table. So these are like, you'll understand what this all how these are related to network stuff. Okay, so this associations. Okay, we need for private subnets. Okay, so this is just the description that I gave. You can give whatever is convenient for you. Okay, so I can just minimize this so that you can see this full section, or let me, yep, yeah. So that is the local section, and now the VPC part you can see in the right side. So for this VPC resource, so whatever is needed, just you go to the registry and search for a particular thing, and then you'll be good to find the syntax or what is the params that are needed for particular resource creation. In AWS, you can just refer to this. Okay, I'm just giving you the place where to look for to create particular resource in whatever the provider that you're going to use. Okay, so this is for VPC. So I'm just going to mention this is like VPC section. So this is going to be this AWS VPC. Okay, and the name for it, I'm just going to give this as a main. Okay, so yeah, and here this CIDR block, I'm just going to give in here this as the value. Okay, and we have the default params that we can configure. So I'm just going to configure whatever is this value that we have in the documentation. Okay, and the tags, so it's better if we wanted to monitor stuff and all, which is taking how many resources and all. To keep track of that, it's better to give tag name for our particular resources that we are creating. Okay, so this I'm just going to give here this dynamic value. So whatever variable dot this project id, so that will be like act as a unique identifier to whatever how many of our projects that we create. Okay, so this is going to be this variable project id separated by iPhone, and then the environment, and then the type of application. It's going to be web application. Okay, so this is the VPC resource block. Okay, so next is the subnet. So same way you can just search for this AWS subnet. Okay, then you will get this resources. Okay, so this is the syntax or params that it expects. Okay, so I'm just going to we are going to define two subnets, one for public. Okay, so I can just document this. So public subnet, nothing but these are like internet facing subnet, whenever we wanted to talk to pulling public Docker images or something like that. Okay, so I can just mention the same. So this is nothing but the internet facing, this nothing but load balancer and this gateways and all stuff. Okay, so here I'm just going to create in here this AWS subnet. Okay, and the name I'm just going to give in here public subnets. Okay, fine. And here let's we can these are the params that we are supposed to configure, and also we can configure the count of these resources that we wanted to create using the count param. Okay, so here nothing but here this count. Okay, and so this one I'm just going to give in here. So minimum I'm going to create a 2, because the length of the availability zones that we have defaultly given were 2 availability zones. Okay, and so whichever is minimum, so that we are going to create. Okay, so I can just comment the same in here. So this is minimum of 2 subnets we are creating for our public, that is for sure. Okay, so fine. And now this the VPC ID under which virtual private cloud we are creating this subnets. Okay, so this one we can just refer to this the above resource, this AWS VPC dot main, and then the ID. This is going to give us the ID, so I can just output of this resource we will have few params. Okay, I'm just assigning the ID which is needed for this parameter. Okay, and then the CIDR block. Okay, so here we are going to refer to our the subnet variable dot this subnet public CIDR block, and I'm just going to assign in here the index, particular index. Okay, and then the availability zone. Okay, so here as well we are going to refer to the variables that we define. So basically, since we are going to create if we are going to create 2 resources, first index 0 it will be, and the second index will be 1, and it will just pick up the 0th value in this list of a string of these variables that we defined. Okay, I think this it'll pick up this, and for next thing it'll pick up this, and so on. Okay, fine. So that is the availability zone. Okay, and then finally the tags. If we want, we can just give the name for this. So I'm just going to give the name as something like subnet public, and mention in here this availability zones value. Okay, so I can just use the same index. Okay, so this is the block for creating our public subnets. Okay, and then same way we can just use this to create the private subnets. So I'm just going to change the naming convention to this as a private subnets. Okay, so this is not going to be internet facing, this is going to be the internal facing thing, kind of whatever our applications or db or whatever. Okay, other applications which are private and we wanted to not expose to the outside world. Okay, so this is going to depend now on this subnet private CIDR block. Okay, and this VPC ID is going to be pretty much same, and here this is going to be now the private CIDR block. Okay, so I can just give the same subnet CIDR block. Okay, fine, and the availability zone, and then the name for the tag I'll just change public to private. Okay, fine. This is the resource to create private subnets. Fine. Now the internet gateway. Okay, so if I just showcase you the diagram, so this is the resource we are supposed to create, the internet gateway. So for that also we have the resource, so you can just search in here as the internet gateway. Okay, so I can just so this is the resource we are supposed to create for us to configure internet gateway in our AWS provider. So I'm just going to specify in here this as internet gateway. Okay, so this resource, it's going to be this AWS internet gateway, and the name for this I'm just going to give in here this main name, and the required params is nothing but the VPC ID. So this is going to be nothing but our virtual private ID which we are going to create above, and then the tags. Okay, so I'm just going to give this as internet gateway public. Okay, so pretty straightforward tag I'm just giving for this. Okay, and then the elastic IP. So basically I'm just going to create elastic IP. So I'll explain you why do we need this. So just search for EIP. Okay, so basically what is the purpose of this is nothing but see, we'll be assigned the ephemeral IPs. So what does this mean is basically let's say I'm just giving you one instance or use case or an example so that you'll better understand. Let's say you have created one EC2 instance or two EC2 instances for your applications, and then you are starting the instances whenever you're developing something or whenever you need, and later whenever you're done with your development and you wanted to stop the instances and later again start and use it whenever you are in need of. So whenever you stop, whatever the IP addresses were allocated for you will be deallocated for you, and will be freed, and then will be assigned to some other people who are using the EC2 instances. But if you want the specific IP address to be with you as long as you have those instances up or down until you destroy them, you want particular IP address dedicatedly assigned to you. That's where we go for elastic IP. So this is not ephemeral in nature. Basically this will be with you as long as these instances that you created are not destroyed. So that's the purpose of elastic IP address. If you want more info, you can just google this stuff, or refer to this documentation. You'll understand what's its core need. Okay, so I'm just going to create the same, so elastic IP, and here I'm just going to give the name this to be Nat IP. Okay, and here we have this extra quotation. Okay, and this count, this is going to depend upon this NAT gateway count. Okay, and VPC, I'm just going to mention this to be true, so you can just understand what each variable does. Okay, so basically this is deprecated for now, but we can just keep this is going to work. So just there'll be workaround as an alternative what we are supposed to use if we want the same functionality that we'll achieve with this variable. As of now, I'm not going into that. You can just refer to documentation and configure whatever the value that we are supposed to. Okay, fine. So this is for elastic IP thing, and now this the NAT gateway. So this NAT gateway is nothing but this ones. Okay, so for that also, so basically all or nothing but whatever we are needed, those are nothing but the resources in a Terraform terms. Okay, so I'm just going to create this NAT gateway. So let me just give this as a subsection for NAT gateway. Okay, so here I'm just going to give here only use one. For now we are just going to use one NAT gateway for both the availability zones, but it's an ideal way of doing it is having a separate NAT gateway for each subnet or the availability zones. Okay, since we are but just one NAT gateway works pretty well, but if you want to have a separated dedicated NAT gateway for each of subnets or availability zones, it is recommended to go ahead and create the separate NAT gateway. Okay, fine. So this is the so as I'm just specifically mentioning kind of these are stage or dev environments assuming. Okay, so I'm just fine, and here let me just create in here this AWS NAT gateway, and the name for this I'm just going to give in here something like NAT public. Okay, fine, and this count, this is going to be nothing but this local NAT gateway count, and then the allocation ID. So if you want what does this allocation ID means and all, you can just refer to this. Okay, and this is nothing but this AWS elastic IP the resource which we create above. This is going to give me this ID, so this count dot index.id. Okay, fine, and then the subnet ID. So here I'm just going to use this public subnets, and the respective subnet index ID will be assigning, and then the tags. Okay, so I'm not going in depth what each param does for a particular resource. Those are self-explanatory and are properly explained in the documentation. Okay, I mean, at least these are prerequisite, having a brief idea of what is Terraform and what is AWS and all stuff. Okay, so if you want even in-depth explanation, just comment. I will try to explain in more elaborative manner in the next videos. Okay, so the name or the gate tag for this, I'm just going to give here it as a Nat Gateway, and I'm just going to assign this availability zones value. So this is going to be, yep, this is the tag. And so let's say whenever we are trying to create a particular resource using our Terraform commands, if this resource is relying on particular resource that we are creating, since this will be created in parallel, but this depends on particular resource. So in that case, if we just give in here this depends upon, so it will make sure whatever this resource is depending upon will be created first, and then this resource will be created, so that will not face any issues. Okay, so this is depending upon this internet gateway dot main. So I'm just calling out this as a dependency for this resource to be created. So what it does, this will create this resource first, and then it will create our NAT gateway. Okay, so this is the NAT gateway, and then the route tables. Okay, so we are going to create in here this route tables. So same way I can just show you the same for this as the route tables. Okay, so there is pretty clear explanation what it is and everything. Okay, so I'm just going to quickly create this resource. So here this AWS route table. Okay, and the naming, I'm just going to say this as RT, which stands for route a table, and let me just give this as a public. Okay, fine. And the params for this is the VPC ID, so I can just give in here this ID. Okay, and then the route. Okay, so here the CIDR block, so I'm just going to give in here everything for now. Okay, and then the gateway ID, so you can see here. Okay, gateway ID, so this is going to be nothing but AWS internet gateway dot main dot ID. Okay, and then the for so here this, yeah, that is the issue. Okay, fine, the syntax. Okay, and then this IPv6 CIDR block, so just this is how we specify for IPv6, correct? And this gateway ID, so this is going to be this internet gateway main dot ID. Okay, and then the tags, I'm just going to give in here the tag to be route table public. Okay, so just this is just the public route table. Okay, and then the for the private. Okay, so we are going to create the same for no private stuff. Okay, so let me create this route table. This is pretty not for beginner, so these are pretty important network concepts. It's good to know, but eventually you will get there. Okay, so maybe you might feel these are pretty complicated topics, but just listen, you'll understand, and then just look out for more information as you just keep on developing or creating this resource. Okay, so this count, I'm just going to depend whatever NAT gateway count is, and here this VPC ID, so this is the whatever the VPC ID that we are going to create. Okay, and then route here, so the CIDR block. Okay, the pretty much the same like we did for public, and here this NAT gateway ID. So here if this NAT gateway count is greater than 2, okay, then I'm going to use this the particular index. Okay, so here this count dot index dot id. Okay, if not I'm just going to assign the 0th index id. Okay, so here NAT gateway. Okay, and the 0th index and the id. Okay, so this is the NAT gateway id. Okay, and finally the tag. Okay, so for tag thing, so the name I'm just going to give in here this as route table private, and just for which availability zones I'm just going to use this count dot index. Okay, and give that availability zone value. Okay, so this is the route table for our private. Okay, and next the associations, and then the so if you just look at this things, we'll have to configure first the route table association, and then this network access control list. Okay, and then the that is for public and private. Then that's it, we should be good to go with our network module. Okay, so let me create now the public route table associations. So same way for that also we have the this route table association, so pretty self-explanatory as well. So I'm just going to create the same. So this is going to be this route table association, and the name for this I'm just going to give public route table this as the associations. Okay, and this count I'm just going to depend upon this AWS subnet dot public subnets. Okay, fine, and then the subnet id, so we will just refer to this public subnets of this particular id of subnet. Okay, and then the route table id. Okay, so this is going to be nothing but this AWS route table dot public list dot id. Okay, so this is for public route table associations. Okay, so same way we are going to create it for the private. Okay, so this is going to be the same resource, and let me just name this as private route table associations. Okay, and here this count again this is going to depend upon this private subnets. So I'm just going to change in here thing, and the subnet id, so this is going to be AWS subnet dot private subnets. Okay, so I can just rename this to private subnets. Okay, and this particular count dot index dot id. Okay, and then the route table id, so this again if this grid it's greater than 2, same way I'm just going to use this AWS route table dot this route private of this particular index id. Okay, if not we will just assign this the 0th index id. Okay, so this is the private route table association. Okay, and finally one thing we have left is to create this network access control list. Okay, so this is the thing. Okay, so for this resource, okay, so we can just refer to this the network access control list. Okay, so you just search for so yeah just yeah, yeah, so this is the resource. Okay, so I can just create the same resource AWS network access control list. Okay, and for this the name I'm going to we'll have again both for public and private. So I'm first, let's create for public. Okay, and the VPC ID, so this is going to be our VPC main dot ID. Okay, and then the subnet IDs, this is going to be AWS subnet dot our public subnets, and how many our we have, this is going to give us those all IDs. And here this ingress, so this is nothing but which we are allowing from which IP addresses and all stuff. Okay, so since this is public, so this is going to be open to things. So this roll number, to understand what this each means, you can just refer to documentation. As I mentioned, I'm not going to explain in detail each and every parameter purpose. Okay, and here the CIDR block, this is going to be if needed just comment, I'll just redo this thing. Okay, fine. And from port anything 0 to port 0. Okay, this is the ingress. Okay, and same way we can configure this egress. Okay, see the outgoing thing. Okay, so this is going to be pretty much the same, so I can just take a refer from here. Okay, so this is the egress, and we can just give the tags for this. So in here let me this tag. Okay, so the name for this let me give in here the name as this network access control list public. Okay, so this was for public network access control list. Okay, and now the private thing, so I can just do one thing, just copy this thing, and we'll tweak the changes as needed for our private network access control list. Okay, so here first the name, I'm just going to change this to private. Okay, and here instead of this public subnet ID, so this is going to be this private subnet IDs. And now ingress, so that is the incoming, so we can be specific for incoming. Okay, and the first is the protocol, it is TCP. So since it is internal, okay, rule number, and then allow CIDR block, and from which port we are going to allow only from port 22. So this is the thing. Okay, and so other ports, if you want, we can just keep on adding more ingress blocks. So I wanted to allow from the 80 port as well, and for HTTP, and if it's HTTPS 443 port and all. So we can just change in here this to the port number 80. Okay, so this is like pretty restrictive in nature, so we are only allowing from particular ports. Okay, and the same way I can just change this for 443. Okay, and here as well to 443. Okay, fine. And finally one more thing. Okay, so let me change rule number here. Okay, fine. And the port here, this 1024 to the this one upper bound. So fine, yeah, that is the ingress. And now outgoing section, the egress. Okay, so here outgoing. Okay, we will allow from 22 port, 88 port, 443, and same thing. So I can just make the changes accordingly. Okay, and also here this protocol, it's going to be the TCP. Okay, so first thing is 22 port. Okay, so I can just change the same thing for other ports as well. So okay, so let me just change this rule number and the port 80. Okay, and this 443 port. Okay, you will understand this, once you get familiarized with. Okay, and now this finally this egress. So the port 1024 and the bound 655 35. Okay, and I'm just going to change this to tag private. Okay, so these are the resources that are needed for our network section. Okay, so fine, so we just defined the resources that we needed, and the inputs that we are supposed to give for our this module and all. Same way, what is it that we are expecting as an output once we create these resources in our cloud. Okay, so that thing we can just define in our output.tf. Okay, so in here this output.tf section, so once we create this thing, what we expect is the public subnets and private subnets and the VPC ID. Okay, so that we can use in our main section. Okay, so here this value, I'm just going to whatever resources we are creating, which was the AWS subnet. So this is going to give me all the subnet IDs we are creating for public. Same way for the private subnet. So I'm just going to specify the same here from this AWS subnet dot private subnets. Okay, so did I not create private? I'm just going to verify, double check, because I'm not receiving that as a recommendation. And finally the VPC ID. So here this value, it's going to be this VPC dot main dot the ID. Okay, so here, yeah, that is why so this is going to be private. Okay, so that is why we are not receiving. Now we just corrected it, so yeah, we should be good. I mean, I just double check if the names are properly changed or not. Okay, so this is the output that we are expecting from this module. So now we have this module network. So now to use this module in our this main file, it's a symbol. So I'm just going to highlight how we can use this. So once we have this, okay, we can just come back here, and here name for this, I'm just going to give in here this as a networking. Okay, and if this is where the source location that we are supposed to give. Okay, so here once we have in here, so we can see this is where our Terraform files related to this modular setting. So ideally we'll host this in some Git remote repositories, and then we'll refer that URL, and then give in whatever the input variables that we have defined. So in our module, the inputs that we defined was the environment thing. So I'm just going to give this environment, and then the project ID. So whatever we have defined in this, I'm just going to give, and then the subnet public CIDR block. Okay, so here I'm just going to give in for now, okay, this values whatever we have configured as the default values. Okay, fine. And the same way for private CIDR block. Okay, so these values are nothing but whatever we have defined in our variable.tf file. Okay, subnet, private, public, and project ID, environment, and availability zone. So those are the things that we are supposed to give whenever we are trying to use this as a module. Okay, so same thing. So I'm just going to give in here whatever we have given as the default values. Okay, 10.0./24. Okay, fine. And then the availability zones. Okay, so and this is going to be US East 1A. Okay, and US East 1B. Okay, so this is our networking module. Okay, and so same way we will go ahead and create our application load balancer and other stuff. Okay, so before even that, let's just verify uh, whatever we have created, are we able to create this or not. Okay, so for that just let's go to this. I'm just navigating to info directory. Okay, and here let's try to initialize our terraform. So basically the command to initialize is terraform init. So what it does, it's going to create the .terraform file for us, and fetch in whatever the providers the details it's need, and also the modules. If it's a remotely hosted, it will just get it all those related sources that we mentioned. Okay, fine. So this is successfully initialized. Okay, and before even we are trying to actually create these resources in our cloud as a the plan, we can see what it's going to create for us, and what is the change that we are going to see once we try to apply this script. Okay, so the command for this is to terraform plan. Okay, so this basically yeah, so and also see I have configured the AWS access key ID and secret access key, and also default region. So for you to work, there are multiple ways to configure that. So I'm just going to give you quick and the fast way to configure these variables in the terminal. Just I can just comment this to quickly configure AWS correct. Okay, so in your terminal, just I'm just going to comment this. So export. Okay, and the value, so access key ID. Okay, so here goes your key. Okay, so for placeholders, I'm just going to wrap this inside this open close brackets. Okay, so I'm just going to say this is where you are going to set your key, and the same thing for your I mean the access key ID, and this is for your secret access key. Okay, so this is where you are going to get this secret. Okay, fine. And then finally, if you want the region as well to be set to default region, so you can just configure this thing. Okay, so I'm just going to this is how you just run these commands in your terminal wherever you are running, and then try to run those Terraform init and Terraform plan. You shouldn't face any problems. And now how do you create get this access key ID and secret access key? So go to your AWS console and go to your security credentials. Okay, and here this is where, okay, I'm just going to, okay, so basically you can see in here the access keys. So this is since I already have two, so I am not able to create. So basically once you delete this, you will be able to create a new access key, and then you will be given access key ID of this kind. Okay, and also there you will get the secret access key as well, which is private, do not expose to anyone. You will get it from there, and then use that secret access key. Okay, so this is how you can get this values for particular AWS access key ID or secret access key. So this is like, temporary solution. So basically every time you wanted to run this Terraform scripts, you are supposed to configure the scripts. But let's say if you want the kind of permanent way of configuring these scripts, there are multiple ways. So if you're on Mac, you can just have this variables the same way that we are running in your bash profile script .bash profiles file. You can just edit in your Vim editor or whatever, and just these values you can just configure in there, and then you don't have to configure this again and again. If not, there is again a way in your users location, there will be .aws. You can just create .aws folder, and in that you just have to the file .aws or folder, and then in that you can just configure this as the variables. There is also other way, but these are two ways. I just told you the quickest way. I think this should do pretty well for our use case. Okay, fine. And yeah, so now, so you can see here, these are the 16 resources that it's going to create for us. You can see clearly this is going to help me create the VPC and all. So basically it's going to give us the blueprint of what we are going to create in our cloud, like we say exactly the blueprint architecture that we saw. So yeah, so basically just to configure this is working fine or not, I'm just going to run this the command apply. So once we run this command apply, it is going to create the resources whatever we have defined in our modules or the variables and all stuff. Okay, so let me just quickly show you this one. So basically if it's going to ask you for your consent to approve it or not. If you want to avoid that consent, so you can just give this auto approve flag. Okay, so that it will not ask you for your consent. So once I run this, so this is going to create whatever the resources that we have added in our scripts. So you can clearly see that these are the resources that it is creating, and I'll show you in the here as well in this home section. So let me wait for it to create, and then I'm going to showcase you what and all this created. Did this create exactly whatever we asked to? And this is like declarative way of asking to create the resources that are needed. So once this is created, I'll be pretty confident that the network module, that whatever we wanted to create for this network section, is creating properly. And next we'll jump on to this compute section. That's where we will configure the application load balancer and all of this stuff. Okay, so I'm taking it slow, okay, so that you'll better understand. Basically this is pretty generic and standard template, guys. Okay, so once you master this thing, so it will be pretty easier for you to deploy any kind of infrastructure needed for your application. So hope so this will strongly act as a template for you guys to deploy your infrastructure. Okay, so it will take some time. So you can see here it is taking some it's creating, and giving us the immediate status back to us, what it's happening, what is it's creating and all. So we can see, so I am in US East one region itself. Okay, so this is going to create the network sections and all for us. So if I want you to show, so I can just show you this network sections. Okay, basically you can see in here the security groups and all. Okay, so let's wait for it to create. Okay, yeah, this apply is completed, and 16 resources are created. Okay, so let's just check it out. Okay, so I just wanted to check the same. Okay, so let me just check the elastic IP. Okay, and everything. So network interfaces, let me just showcase you. So better if I show you, let me just maximize this part. Okay, yeah, so you can see here, this is the VPC this is created. So I'll just show you a few of things, not all of the stuff, but it's pretty clear indication for us this all are created. So you can see here, this is the name that we configured for our VPC section. So if I just go in here for our VPC thing, the project ID that we gave was the resume builder app broad web. So here, this one. Okay, so this is the thing. So basically it has created our VPC. Okay, and this is where we are having, you can see here, we have two private subnets and two public subnets. Okay, so it has created for us, you can pretty much see this is associated with our the resume builder. So I can just expand, you can see here. Okay, and then the route tables. So this has created this public and private two subnets in each section. Okay, and here, okay, and the internet gateways also it has created for us this under this VPC ID. Okay, and egress stuff, NAT gateways and all. So you can see here. Okay, so basically pretty much whatever we need. Okay, this has created for us. Okay, and for the network stuff, whatever is working. So once you're done with the thing, so basically if you're not doing this all in a single stretch, if you wanted to create incrementally, you can just, now whatever we have created, we can just run this terraform destroy command. Basically this, what it does is, whatever we have created, it is going to restore that state, and then using that state, it is going to destroy all the resources that we have created using our terraform scripts. Okay, so now whatever 16 resources we have created, once we run this command, it should delete this. So I'm just going to showcase you this. So once I run this terraform destroy, you can see that it is refreshing the state, and then whatever resources we have, so it is going to ask for again confirmation. So just press type in yes, and it is going to destroy all of the things. So now let's just see, this I'm just going to give you one confirmation whether this is working or not. So we have this VPC now. Once this is successfully completed, we will not see this anymore. Let's wait for it to complete. Okay, so it will take some time since we have quite a resources to destroy. So like it took time for creating, the same way it takes some time to destroy it as well. Post this destruction. Okay, so you can see the message in here. This has successfully destroyed our 16 resources whatever we have created. So if I just refresh, you can see the VPC which we had before, we're not seeing it now. That means the resources that we want or we created were successfully destroyed. Okay, this is how we create incrementally the modules or resources we want at a time one step at a time. Okay, so next thing I wanted to focus on is the application load balancers and those things. Okay, compute section, we will like we did create the module for network. Same way for application load balancer also we are going to create a module for that, so that we will develop the scripts in isolation, so that those can be written idempotent and can be reused across our code base. Okay, yeah, next thing I will move on to application load balancer.